Okay, so what we wanted to do, I'm just going to recap because I'm recording now. We went to Google Classroom, we went to NJSLI practice, we clicked the practice tests. Then from there, we're going to scroll down and we're going to click mathematics, scroll down again, go down to geometry, scroll down again, and we're going to go to Geometry Unit 2 and press Start. You don't have to enter your name. We could start as guest. Start again. I just want to show you a couple of things on here. First thing I want to show you is the calculator. So in the calculator section, on the calculator section, there is the TI-84 graphing calculator. But guys, this is a huge thing. If you do not do it, all of your answers will be wrong. So geometry, we did trig, right? SOHCAHTOA, that was the unit we used our calculator. What you want to make sure is that it's in the right setting. And anybody that had a TI-84, I had done this with you in the start of our trig unit to make sure it was in the right setting. But now if you don't do this, it won't be in the right setting and you're going to get those questions wrong. So first thing you want to do is go to click your calculator. You're going to go to, I think, second. What was it? Nope, sorry. Mode, sorry, not second. You just press mode. And then, can I make this zoom in? I can't. But if you guys are following along on your computers, if you notice 1, 2, 3, fourth down, it's highlighted black on radians. We don't want radians. Do you remember what we wanted? Degrees. We want degrees. So what you're going to do is you're going to scroll down, click over to degrees, and then press enter. All right, once you do it one time in the session, you're done. But if you log out of TestNav, if there's like 2 days of calculator sections, I don't really know how it works. The next day you sign back in, you have to redo this. So it will stay in degree mode for the remainder of this session. But if there's another session the next day or whatever it is, you have to redo this. Everybody okay with that? So it is a pretty big deal if you forget to change it to degrees. Anybody have any questions on that? Okay, the other thing I want to show you on TestNav is right here. Do you see where it says, I'm right here. This is so sneaky and it's so small. Go all the way to the right. What do you see there? That little tab, exhibits. You want to click on that. And what do you get? You get a whole bunch of formulas. And look here, all of our area formulas. Do you see this? Area of a triangle, area of a parallelogram, area of a circle, volume formulas. This is what I'm going to show you today, some of the volume formulas and how to use them. So you don't need to remember the volume formulas, but I'm going to explain to you what these variables mean. So if you get a volume question on the test, you can just know how to use the formula for it. So this is the end of what I want to show you inside the test nav that you're going to be in. Any questions on how to change into degrees or where to find the formula sheet? Okay, so now what I want to do is go back to Classroom. And I want to go here where it says overview of surface area and volume. And I'm happy to say that we've already done all of the surface area, right? We've gone over all those formulas. You know how to use them, so that's great. What we didn't get to is volume. So that's what I want to explain to you now is how to find the different volumes. So scroll down to where it says volume. And I wonder, is my test nav still up? Okay. So here, like I said, You have all the volume formulas here. So it's just a matter of knowing how to use them. All right, to find the volume of a rectangular box, I think everybody always remembers this one. It's the length times the width times the height, right? We all know that one. L is length, W is width, H is height. Okay, to find the volume of any prism, it's going to be this capital letter B times H. Just to show you, right here, general prism, volume equals capital B times H. Same formula. And that capital letter B, this is where it's going to be different. Usually we see B and we're like, oh, that's the base. Yeah, but we usually use a lowercase b to represent the base. This capital letter B doesn't just represent the base. This capital letter B represents the area of the base. And H represents the height. Okay, now I'm going to show you for cylinder. It's written differently on the formula sheet, but I'm going to actually explain to you how it's the same as a prism. So for the formula sheet, the cylinder says pi r squared times h. Pi r squared times h. What I'm going to say to make it the same as a prism is I'm going to say capital B times h, which is really the same formula as the formula sheet. Why? Capital B represents area of the base. Well, what's the base? Isn't it a circle? So that's where they're getting the pi r squared from, times the height. Now, the pyramid and the cone are a little bit different. Instead of area of the base times the height, it's going to be 1/3 capital B times H, where remember, capital B represents area of the base and H represents the height. So the prism and the cylinder are the same, and the period and the cone will be the same. So the cone is also going to be 1/3 capital letter B times H. And lastly, the volume of a sphere is going to be 4/3 pi r cubed. And just to show you, you do not have to have these memorized. For the NJSLA, they are all here. Look, prism, area of the base times the height. The cylinder, it's the same as the prism. They're just putting the area of the base formula in. The sphere is 4/3 pi r cubed. The cone is pi r squared h. Well, I did area of the base, but the base is a circle in a cone, so that's where they're getting the pi r squared. And then the pyramid is what we wrote down, the 1/3 area of the base times the height. So like I said, if you just understand how to use these formulas, you don't have to memorize them for the NJSLA. So let's keep going. Let's figure out how to use these formulas. All right, find the surface area and the volume of each figure. We're good with surface area. I'm just going to find the volume. So to find the volume, this is a rectangular prism, so we're length times width times height. So the volume is going to be 5 times 6 times 7. So we have 30 times 7, which is 210. And now for volume, it's not units squared, it's units cubed, because we're now seeing how many three-dimensional cubes can fit in a space. That's what volume says. How much can we fit on the inside? That's what volume tells us. Now, I'm not going to have us do surface area, but just a reminder, what action do I have you pretend you're doing when you're finding the surface area? What activity? Do I say envision we're doing what? Painting. So if we were to find the surface area here, how many rectangles would we be painting? How many? 6 rectangles. So for the surface area here, it would be find the area of the 6 rectangles, then add. Right? Isn't that what we would have to do there? Okay, let's keep going. So I think this is supposed to be that the whole diameter is 6. So if the whole diameter is 6, what's the radius? 3. So to find the volume of the sphere, it's 4/3 pi r cubed. Well, our radius is 3, so this is 4/3 times pi times 3 cubed. And 3 cubed is not 9. 3 cubed is 3 times 3 times 3, which is 27. Because multiplication is commutative, I'm going to do 4/3 times 27 times pi. And then I'm going to cross simplify. 3 goes into 27 9 times. So our volume ends up being 36 pi units cubed, or centimeters cubed. All right. All right, we'll do the rest of these. All right, so if I want to find the volume of the cylinder, remember the volume of the cylinder, I put capital letter B times H. What does that capital letter B represent? It represents area of the base times the height of the whole prism. Or cylinder in this scenario. All right, what is the base? Yeah, what is the base? It's a circle. And so to find the area of the base, it's a circle, it's pi r squared times h. Well, if the diameter is 14, the radius is 7, so we're pi times 7 squared, and then the height of the cylinder is the side right here, which is 8. So we have 49 pi times 8, and we can multiply these. If we're multiplying 49 times 8, we are going to get the volume is equal to 392 pi kilometers squared. All right, number 4 is a good one. This is a prism. How do I know that it's a prism? Well, it has parallel congruent bases, so these are triangles, and then it's rectangles in the middle. Right? So this is our quadrilaterals, parallelograms, or rectangles in the middle. That's what a prism is. So to find the volume of a prism, it's capital B times H. Well, that capital letter B, no matter what kind of prism I give you, is area of that base. Well, in a prism, that base is always changing. In this scenario, the base is what shape? The base is what shape? It's a triangle. It could be a hexagon, right? We could have a hexagonal prism. All right, so whatever it is, we find whatever the area is of that base. So capital letter B is area of base. times the height of the prism when, and I'm going to put a star here, when standing on the base. So it's the height of the prism when it's standing on the base. So right now, if this were flipped and it was standing on one of the rectangles, that's not the height. You want to make it stand on its parallel congruent bases and then decide how high up it's going. So do we agree that the height is right here, 4? That's how tall it is on the side going up. And now the area of the base is area of the triangle. Well, to find the area of the triangle, it's half base times height of the triangle. And now here, I'm going to take the triangle, one of the bases, I'm going to take this bottom one. And because of that right angle there, you see that here's the right angle, this is 8 and this is 6. So doesn't that represent a base and a height because of the right angle? So the base is 8, the height is 6 here. So to find the area of that, the area of the triangle is half the base is 8, the height is 6. Half of 8 is 4. 4 times 6 is 24. So now our area of the triangle is 24 times 4, which is going to be 96 kilometers cubed because we're finding the volume. Okay, the only other thing I want to show you is, let's use the cone and the pyramid are the same formula. Let's go to the pyramid where the volume equals 1/3 capital B times H, where the B is area of the base. Well, what's the base in this specific pyramid? It's a square. So the area of this base is side squared times the height of the whole pyramid. Now, the height of this whole pyramid is not the slant height, right? The height of the whole pyramid, isn't it the altitude which comes to the middle? This is the altitude. And so I need to find the height of the altitude. Well, if you remember, guys, the altitude connects to the center. So if the length is 6 from the center to the rim is 3. And then we have a triple, 3 something 5. What is it? 3, 4, 5. So now we're going to have 1/3 times the side of the base squared. So that's 6 squared times the height of the whole pyramid, which is 4. So now we have 1/3 times 36 times 4. 3 goes into 36 12 times. 12 times 4 is 48 inches cubed is our volume. All right, we are actually going to have the rest of chapter 12 is volume. So you got a little nice sneak peek into what we're doing after surface area. But anybody that's taking the NJSLA, any questions on any of these formulas or how to use them? We're good? Okay, great. So then that's the end of anything I wanted to show you for the NJSLA. What I want to do now, actually, I'll stop sharing this.